Okay, so today we're going to take a look at our last review for our air test, which was coming up. So this will kind of encompass some of the probability problems that we did in Module 10, and also some of the circle, and some of just kind of the miscellaneous stuff that you might see on your test. So this problem says, Francisco asks students at school what pets they have, and he studies the event shown. Event S is the student has a cat, and T, the student has a dog. And we know that they're independent, so that's very important. Remember, that means one is not influencing the other. Find all the equations that must be true for S and T. Well, if it's S and T are independent, then the biggest one we can have is we know the probability of A and B, or in this case the probability of S and T, is just going to be the product of their individual probabilities. So that's probability of S times the probability of T. So in this case, that would be this choice here. Remember, this intersection sign is the same as and. In class we used and, but we also had spoke about how the test sometimes will use this intersection. The other big thing is, since they're independent, we know S happening does not affect T, and vice versa. So we know the probability of T happening, given S has already happened, is going to still be the same as probability of T. Because remember, this conditional probability means given this has happened. So even if S happens, the probability is still the same. So that would be this choice. And the same thing is true because for S, so if I say what's the probability of S happening, given T is already happening, well, T happening does not influence S, so this would just be the probability of S. So this choice would be true. So the big idea that they're independent is one happening is not going to influence the other, so even if S has happened, T is still the probability, or T happening, S is still the probability. Okay, here's another very kind of simple one that uses that same logic from the first problem. It says two events A and B are independent. So since they're independent, and we're talking about an AND problem, we know the probability of A and B equals the probability of A times the probability of B. Well, in this case, the probability of A and B is 0.24. So we can put that number right there. And the probability of A is 0.3. And the whole goal of the problem is to find the probability of B. So for that, I'm just going to put like an X, something I don't know, because this is what I'd like to find out. So all we simply have to do is divide both sides by 0.3. So we get 0.24 divided by 0.3, which is 0.8. And if I take 80% times 30%, I get the 24%. Okay, here's where we have a table. We're going to try to fill out the table, then kind of talk about some of the probabilities. A total of 200 people attended a party as shown in the table below. A person is selected at random to win the prize. The probability of selecting a female is 60%. So let's write that. Probability of selecting a female is 0.6. The probability of selecting a child is the probability of selecting a child given that the person is female is 25%. So we're basically saying the probability that the person is a child given they're a female. So we already know this person's female. What's the probability? And the probability that they're a child is 25%. So the probability of selecting a male given the person is a child is 40%. So we want to fill out this table to show the number of adults, children, males, and females who attended the party. So let's talk about the first one first. So the probability they're female is 60%. Makes sense. There's 120 out of the total 200. 120 out of 200 is 60. So let's look at this probability to see exactly what this tells us. This says if we know they are a female, the chance they are a child is 25%. Well, how many of the females do we have? If we look at this row, we have 120 females. So if we know they're a female, given they're a female, we already know they're a female, so we're really only talking about 120 people. So this 25%, whatever it was figured out of this 120 people. And basically the chance that they were a child was 25%. So really the number of children out of these females is going to be 25%. So if we go over here and we just look at that equation, 0.25 equals x over 120. All we have to really do is multiply by 120. Or you can just know kind of that that's going to be 30, because 30 divided by 120 is the 125, or 0.25, pardon me. So the number of children here would be 30. And then, of course, the number of adult females then would have to be 90, because this row has to add to 120, and 120 minus 30 would be 90. Okay, secondly, let's look at this table. It says the probability they are a male, given they are a child, is 40%. So basically, we know they are a child. Okay. Now we could use that probability, or even easier, since we have this row total, this would probably be even easier way to do it. We know there's 50 total, there's 30 given, so I know this has to be 20. Same thing here, just to save us some time. Not that the same logic wouldn't work. If this is 150, this is 90, so this would have to be 60. And then 60 plus 20 is 80. So really the only logic here was really just trying to figure out this one. This was kind of not really needed. We could have used this, but we really didn't need to, because we could just kind of take the totals of the columns and work backwards. Okay, Sam is picking fruit from a basket that contains many different types of fruit. Which of the events is independent? He picks a kiwi and eats it. He picks an apple and eats it. He picks an apple and eats it, and then he picks another apple and eats it. He picks a kiwi and eats it. He picks a kiwi and puts it back. He picks a kiwi, puts it back. He picks an apple, puts it back. Now, the only ones that are going to be independent is going to be D. Because if I pick a kiwi and eat it, there are less fruit in the basket, so it's going to be a different number that I'd be dividing for my probability. Same for this, same for this. The only one's going to make it independent, because if I have this basket of fruit and I take a kiwi out, well, if I don't put it back, there are now less fruit in the basket, so it's a different probability of getting a kiwi, an apple, of everything else. Just like our cards, if we pick a queen, there's less queens and there's less cards. So if I don't put that card back, then they are not independent. So this says the probability of flipping a fair coin and landing face up or heads up is 50%. The probability of rolling a fair number cube besides 1 through 6 and getting an odd number is 50%. So it's what's the probability of flipping a head or rolling an odd number. Now, if you remember, or just means we add the probability. So the probability of a head plus the probability of getting an odd. The issue here is that there is overlap. It is possible to get a head and an odd at the same time. I can roll a head and a 3, and I've gotten that. So what we have to do is we have to subtract all the overlap. So the overlap would be them happening at the same time. So the overlap happening at the same time would be the probability of a head times the probability of an odd, because when you're doing an and, you multiply. So this would be 50% plus 50% minus 50% times 50%. So this is 1 minus 0.25, which is 0.75. So it kind of makes sense that it's not 1. You just can't add them together because we know that it's not guaranteed that you'll get a head or an odd. So we know we have to subtract something else out. Okay, let's move on to a problem about a circle, something we've covered very recently. A teacher draws circle O, angle RPQ. So RPQ is this angle. Notice it touches at the edge. And angle ROQ, this one is in the center. And the teacher asks the correct relationship about these two angles. The measure of angle RPQ is equal to the measure of angle ROQ. So are these angles the same? Well, we should know they're not, because we know if an angle's on the edge, then we know the arc is going to be double that. But we know if the angle is in the center, then the arc is the same, so x and x. So it's not actually going to be the same, it's actually going to be half. So if we think of this arc as x and this is 2x, then this angle is actually half as small as this angle. So claim 2 is correct, where it says the measure of ROQ is twice the measure of RPQ. And it says justify your answer, and here would be a really nice answer. I would just say angle RPQ is inscribed. So it's half the arc. But ROQ, angle ROQ is central. So it's equal to the arc. And since they have the same arc, we know the angles, the inscribed has to be half of the central. Okay, so let's look at this problem. The planets in our solar system can be modeled by spheres. The diameter of Jupiter and Saturn are shown in the diagram. The volume of Saturn, so we're talking about volume, is 59.9% the volume of Jupiter. What is Saturn's diameter in kilometers? Round your answer to the nearest thousand. So the first thing we need to know is what is the volume of a sphere? And the good news is all these formulas are given on your formula sheet during the test. So the volume of a sphere is going to be 4/3 pi r cubed. So the first thing I would do is I would go ahead and I would figure out what is the volume of Jupiter, because I know what its diameter is. So if I look at Jupiter, it has this big diameter, this 14,984 kilometers, but the radius would just be half of that. So half of that would be 71,492. So now I can find the volume of Jupiter. It is 4/3 pi, and then this horrible number, 71492 to the third power. So this volume is going to be, so the volume is this huge number. It's 1,529,821,375,259,083. And this would be cubic kilometers. So it's a really, obviously it's a planet, so it's going to be really big. So now we know really everything about Jupiter. We know its volume, we know its radius. So now we can move over to Saturn. So it says Saturn's volume, it's a smaller planet. It's only 59.9% of the volume of this planet. So I'm going to multiply that number by 59.9 in decimal, obviously, so 0.599. to get the volume of Saturn. So the volume of Saturn, since it's 59.9% of Jupiter, is going to be 916-363-003-780-190.8. So now we know that is going to equal 4/3 pi r cubed. So if I basically take that number and equal 4/3 pi r cubed, I can solve this equation. So what I'll do is I'll divide both sides by 4/3 pi. I mean, you have calculators, so use them. And that will give me r cubed equal to this number, which I get to be 218,876,513,641,765. And now, to get rid of a square, we take a square root. To get rid of a cube, we use what's called a cube root, which is a function on your calculator. So we'll take the cube root of both sides, and that will give me the radius of this planet. So the radius of this planet, Saturn, is going to be 60,265. We're going to the nearest thousand, so that would be 0.170. So for the diameter, I would just double that. So times 2, so the diameter of Saturn is 120,530.340 kilometers. Okay, here's kind of another volume one. The cross-section of the right triangular prism created by a plane cut through the points shown below and is also perpendicular to the opposite base. So if I have this triangle, this prism, and I cut here, and I go straight down, and then I go straight over, and I make this plane. Hopefully you can see that the shape that is made here is a rectangle. The top base is a triangle. The bottom base is a triangle. All the sides are actually rectangles. And then this middle plane, perpendicular to the opposite base and kind of cut through these points, is going to be a rectangle. Here is a circle with center O shown. Create the equation of the circle. Well, this is something we just did. We know that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. So the center here appears to be at 1, 1. And the radius I can find, it's 1, 2, 3, 4. So the radius is 4. So all I have to do is plug in that center. So it's x minus 1 squared. Again, it's always the opposite. Plus y minus 1 squared equals r squared. Well, the radius is 4. So 4 squared would be 16. So that's a really easy one if you remember the equation of a circle. But if you can, this is really probably the easiest problem we've done so far. Okay, let's look at this last problem. It says triangle ABC has vertices of -4, 0, -1, 6, and 3, 1. What is the perimeter of the triangle round to the nearest 10? So I can't stress this enough. This is going to probably be a bigger deal on your state test than we probably made it to be in class. But the distance between 2 points is, remember, this formula. x1 minus x2 squared plus y1 minus y2 squared. So what this will be, if we have these points, negative 4, 0, negative 1, 6, which is negative 1, 6 is here, and 3, negative 1 here. So I want to find the perimeter of this triangle, so really what I have to do is I have to find the distance between all these sides and then just add them up. I want to round it to the nearest 10. So I'll find the distance first between these 2 points. So the distance between the negative 4, 0 and the negative 1, 6 is going to be the square root of negative 4 minus negative 1, so that'll be plus 1 because you got the 2 negatives squared, plus 0 minus 6 squared. So negative 4 plus 1 is negative 3 squared, plus negative 6 squared. So this distance is going to be 9 plus 36. So this is the square root of 45. And we're rounding to the nearest tenth, so I'm just going to put the square root of 45 into my calculator and see what I get. So I get 6.7 for that distance. So this distance on this side of the triangle is 6.7. So now I'll take 2 other points. I'll take the last 2, negative 1 and 6 and 3 and 1, and I'm going to do the distance formula again. And I'll see what I get. So the distance formula of this one, square root, so it's negative 1 minus 3 squared plus 6 minus 1, which is going to be plus 1, which becomes positive 1. So negative 1 minus 3 is negative 4 squared. 6 plus 1 is 7 squared. So this is 16 plus 49. So 16 plus 49 is going to give me 65. So the square root of 65 is going to be 8.1 if I'm going to the nearest tenth. So now I found this side to be 8.1. So now I'm just going to do it one more time. I'm going to find the distance between these 2 points, and then I'll just add those numbers up. So we have negative 4 minus 3 squared plus 0 minus 1. So again, minus negative 1 is going to be positive 1 squared. So that's negative 7 squared plus 1 squared. So that's 49 plus 1. So that's the square root of 50. Square root of 50 is about 7.1. So now I've got the sides for each side of this triangle, so I'll just add them up. So 7.1 plus 8.1 plus 6.7 is going to give me a total perimeter of 21.9. 21.9 units for my perimeter. So hopefully you found this review helpful as we do our final preparations to take our air test.